The aim of this experiment was to demonstrate the conservation of energy. Our group discussed multiple methods of experimentation and decided that we would be best able to observe and calculate the results using a pendulum. We hypothesized that the potential energy of the pendulum prior to being dropped from a 90-degree angle should ideally be equal to the kinetic energy of the pendulum at its lowest point of the swing. We discussed that the energy conservation of the pendulum would result in it swinging back and forth, but that its highest point would get slightly lower each swing due to the energy being lost to air resistance. The materials we used included a retort stand, some string, and a weighted bob. The bob weighed 100 grams and was suspended from the retort stand using a 25 centimeter length of string. As the calculations we did used the units of kilograms and meters, these measurements were converted into 0.1 kilograms and 0.25 meters respectively. Once the materials had been chosen and made into a pendulum, the bob was pulled up to a 90-degree angle, dropped and allowed to swing back and forth. This was filmed and the footage was uploaded to video tracking software where markers were placed on the image of the bob at several intervals to determine its velocity. At this point, the velocity was measured using pixels per second, so the measurement of the string was entered to give the software a ratio of pixels per meter to convert the calculations to meters per second. As we hypothesized, the bob's highest point was slightly lower with each swing. While qualitatively correct, we needed to quantify our results. Potential energy can be calculated using the formula mass times gravity times height. We calculated our potential energy to be 2.45 joules. Kinetic energy can be calculated using the formula half mass times velocity squared. Velocity was calculated using the x and y values of the bob at its lowest point given to us by the tracking software using this formula. Taking this answer, we then used this formula to give us the kinetic energy of the bob at the lowest point of the swing. Uncertainties were calculated using propagation of error equations. The uncertainty of potential energy was calculated using the values of mass, gravity, and height along with half of the smallest unit of measure for each value. The uncertainty of kinetic energy was calculated using the values of mass and velocity, again with half of the smallest unit of measure for each value. After plugging these values into the equations, we were given the uncertainties. These uncertainties put the potential and kinetic energies within range of each other, which confirms our hypothesis that the potential energy of the pendulum before it was dropped from the 90-degree angle was equal, when taking into account the margin of error, to the kinetic energy of the pendulum at the lowest point of its swing.